Hi, everyone. I'm Doug Black, Editor-in-Chief at Inside HPC. And today at SC21, we are speaking with, on the far right, Bill Allcock. He's manager of the Advanced Integration Group at the Argonne Leadership Computing Facility. And in the middle, we have Bill Nitzberg. He is CTO of PBS Works at Altair Engineering. Gentlemen, welcome.
Thank you.
Great to be here.
Okay, great. So Bill Allcock, let's start with you. Can you tell us a little bit about the general mission and types of workloads at ALCF?
Sure. Our mission is to enable breakthrough science and engineering, and we help do that by providing supercomputing resources and expertise to the research community, including government, educational, and commercial entities. It's more than just the compute time. If you get an award, you also get access to our computational scientists, our performance engineers, UX, all that kind of good stuff. And in particular, we are looking for the people who just can't get their science done anyplace else or without access to the kind of resources we provide. As far as workloads, we have traditionally been heavy on the classic MPI simulation workload, but recently, and it continues to grow, HPC and AI have become very significant workloads for us.
Okay, so again, sticking at Argonne, how will the Polaris and or the Aurora supercomputers satisfy their missions and user workload requirements?
So every time we turn over a generation of machine, there's a process that we go through. We identify science need, and we work with the vendors on their roadmap, what's going to be available in the time that we are going to need a new machine. We try and keep some diversity in architecture across the DOE. And one of the things that came out of that, it was very clear that heterogeneous/accelerated computing is what was needed. And this made NVIDIA and Altair PBS great options because NVIDIA is a leader in GPUs, and PBS has support for the advanced features that they provide. And then Polaris, which is being installed as we speak, and that's what I'll talk about mostly, is our first significant GPU machine here. We've had small Viz clusters and stuff like that, but it's a 560 node machine, has a 32-core AMD EPYC Milan processor, and 4 NVIDIA A100 GPUs. It's about a 44 petaflop double precision machine. And it's intended to give our users a chance to convert to GPUs if necessary. Some of them already run on GPUs, but some do not. And then to scale up prior to Aurora arriving.
Okay, now here's a question for both of you. Maybe Bill Nitzberg could take the first answer. How did A&L and Altair end up working together?
I'm going to turn it back to Bill, but let me give you like my one sentence. We both were actually focused on scaling up. I mean, obviously, Bill's talked a lot about how this machine is going to be really big and focused on really big science. One of the things that we're focused on at Altair is taking everything, let me use Bill's word too, delivering breakthrough stuff in HPC. Breakthrough to me means 10x. So 10x means don't just go 50% bigger, go much bigger. That means exascale. So Bill, why don't you tell folks how we sort of found each other a couple of years ago?
So since the inception of ALCF, we have written our own scheduler called Cobalt, but it was getting long in the tooth, and we, as Bill said, we needed to scale up, and so we were looking for how best to go about doing that. And we actually initially came to Altair talking about just their resource manager portion of PBS, and I sent my team out to talk to them, and unanimously my team came back and said, "Look, we should just work with these guys. They're a great team to work with. Our roadmaps are incredibly well aligned. I mean, we were practically saying the same things. They have a great system in place already for accepting contributions. So they'll do that. We can contribute. And that's, when your entire team says that's the way to go, you got to listen.
Yeah, and I think that, Bill's maybe being slightly modest about his team, but he's got a set of really expert, longtime HPC folks on board there at Argonne, and it was fantastic to be able to work with folks who focus on really big systems in production, but at the same time are focusing on sort of like the next level of technology and are not afraid to implement it. And so it's been a fantastic collaboration. I think we got introduced by through the exascale computing project as well, which was actually kind of a nice connection to make.
Yeah, that does make sense as you move toward Aurora. Now, as mentioned earlier, you'll be leveraging a lot of GPUs, especially in the Polaris machine. Can you tell us a little more about that and what users will be able to do as a result?
Well, I'm more interested in what we can do. I'm more excited, I guess, about what we can do with it. One of the really cool things about the A100, that's the type of GPU that we have in Polaris, is it has this thing called MIG mode, multi-instance GPU. And what it allows us to do is essentially slice and dice the node, but do it in a hard partition, safe to share with users mode. And so we see the capability of, so these nodes are big, and it is a non-trivial endeavor to try and use 4 GPUs. Some codes can do it, fantastic, go nuts, but some can't. And so this allows us to, we could of course, slice it up down to the GPU level, but even that sometimes is not what they need. What they'd rather have is a bunch more, but they need less. And the MIG mode allows us to do that. And PBS already has support for that. It will recognize, for instance, you can slice the A100 up into 7 MIGs. So if we did that, it would show up in PBS as having 28 GPUs, 4 A100s times 7 MIGs each, automatically. It'll just pick that up. That's great. Now, in the long run, I have some pretty grandiose notions about, I'd like to get to the point where the scheduler can actually alter that on the fly. Can't do that today. That's a thing we would like to do in the future, but it should be possible with effort, and that's why we're pretty excited about that.
I'd say that we have a long history with a long partnership history with NVIDIA, and we spent a lot of time trying to build in special features for, well, the most advanced computing hardware that anybody can get their hands on, like the A100. And so the MIG mode's really neat because, as Bill said, you can take one really big GPU and cut it up. So if you have a really big problem, no problem, use the whole thing. If you have a whole bunch of small problems, instead of using just part of it and getting them done, whatever 7 times slower, you can get them done 7 times faster because you can cut it up into 7 pieces. So it allows a lot of flexibility. And what we did with PBS was we made it sort of configurable so that when you define your GPUs, we actually recognize how MIGs are split up. And we also have an integration with the DCGM Data Center GPU Manager from NVIDIA, where you can actually extract out health information, so you can do sort of health monitoring and status, and you can get metrics about how much GPU memory you're using, so that, in fact, if you allocated, say, a really big GPU, but you're only using a small one, you can get that back from your job. Maybe the next time you can submit the job to a smaller GPU and be more efficient, make a more efficient use of the machine, and as well as use that just for accounting and maybe a chargeback. So I don't know, there's lots of stuff you can do with this. I think it's a really neat technology. It's kind of leading edge technology, which is why I'm really happy to be working with Bill and his team to figure out what we can do. And in fact, he's already mentioned that he's already got ideas about where we're going to go with this, and that's fantastic.
Okay, well, along those lines, what can we look forward to out of the work that Argonne and Altair are doing together?
Bill, you want to go first? Or you want me to?
Well, okay. I could say a couple words, and then maybe you can. The places that we're spending a lot of time in Altair are looking for opportunities for making things 10 times better, right? Which is why we have this really good collaboration with Argonne, who's making something 10 times bigger. So that fits that mode. We're also looking at making throughput 10 times faster with some technology. We're looking at expanding, how to get users to be 10 times more productive by, how they interact with the workloads inside the machines and stuff. I'm hoping that actually some of the stuff that we can do is nuts and bolts, low level stuff. And I think, as Bill already mentioned, the ALCF, Bill, help me out here. It's almost like it's live. Has already contributed some really great enhancements to PBS, and I'm hoping to get more in a collaborative nature with them. But not just around the GPU stuff, but definitely around those. Maybe also around some of the AI ML stuff we're doing together. A little bit around, say, security related stuff. That would be kind of neat. I know, especially for Argonne and government labs and stuff, there's a new security posture sort of coming down through presidential orders and stuff. I don't know, what else are we doing?
Well, from our side, one of the things that we really want to focus on are reservations. So we did some things that we liked in Cobalt, and we would like to bring those over to PBS. It certainly will help our users because it'll behave more like what they're used to, but we think it'll be generally useful for other people. Bill mentioned the security, and clearly I already talked about the GPUs. So I'm pretty excited about that one. And those are the, for the foreseeable near-term future, those are kind of where we think we'll probably focus our efforts.
Yeah, I mean, there's other longer-term stuff. I mean, you guys haven't really played, for example, with some of the other features, I think, that had come along with PBS Professional. But there's the simulator that actually lets you sort of, take last month's workload and rerun it through the scheduler, changing all sorts of parameters or changing all sorts of, actually the neat thing is we can actually split up your A100s in different ways using different MIG modes and see, what the best split is for your workload and stuff. And I'm kind of excited to try to encourage you to take a look at that. I don't know, we'll see where that goes.
And I guess there are two things. It's more, on the Altair side where the effort is being put in, but we are very interested in it and providing input. One is multi-server, that's part of the 10x bigger. So right now you can run PBS with one server or a warm standby. What we want to get to is where we can put an arbitrary number of servers out there and carve up the machine as needed to manage the load. And then the other one, which I'm pretty excited about, is the REST/GraphQL interface, because I was actually just in a workshop before this about workloads, and if we could put up an interface that's externally accessible and that we trusted and had the security levels that we wanted, then that just opens a whole new door for workloads. So we're pretty excited about that piece of work as well.
Neat. Hey, you didn't say this, but I'm going to ask you about it, Bill. One of the things that I really like about sort of our collaboration is it splits the nice difference between the open source OpenPBS and the PBS Pro sort of production stuff. And we're doing a lot of the collaboration in open source, which is fantastic because it really supports that really well. But recently, you guys have decided to use PBS Pro on your production machines, which of course makes sense to me, but I'm biased. Maybe you could say a word or two about that.
Sure. Yeah, all of our contributions are on the open side. We work on open science, right? So we're always going to contribute over there. But we took a look at this and we said, okay, we're talking about bringing up one of the biggest supercomputers in the world, exascale system. And so some of the features that were available in Pro would be useful to us. The knowing that we, for risk mitigation, knowing that we had a paid support contract and we could come get help if we needed it, if there was a significant problem. I leveraged the volume that ALCF was going to be working at, and negotiated actually an A&L-wide site license. So just, the rest of the lab can, if they wish, use PBS Pro for free, because we just bought enough that, we're picking up the tab, and the rest of them can just take advantage of the site license. And I just realized I've been using the terminology incorrectly. I have a bad habit of calling everything MIGs. MIG is actually the technology, but the parts, the individual pieces on the GPU, I should have been calling those instances. So sorry if I confused anyone.
Cool. Thanks.
All right. Well, great stuff, gentlemen. I want to thank both Bill Nitzberg of Altair and Bill Allcock of Argonne for joining us today. And let me wish you both a very successful and interesting SC21.
Thank you very much.
Thank you.